Welcome to Spring LIB.
Okay, so we're doing chapter 23, problem 45. So it wants us to calculate the electric potential due to a tiny dipole whose dipole moment is given by 4.8 times 10 to the negative 30 coulometers. At a point 4.1 times 10 to the negative 9 meters away. Oh, that's how far we want to calculate our potential. Yeah, so at r of 4.1 nanometers away, we want to calculate the potential in three different scenarios. So one is along the axis of the dipole. So let's draw that scenario. So we have our dipole here. We have negative q. We have a positive q. And this is the center of them, which I'll actually draw in red. So we have a center here in red. So along the axis, this is our r vector. Okay, so the equation for potential for a dipole is given by equation 23(7). And that's v equals 1 over 4 pi epsilon naught times the dipole moment times the cosine of theta, which is the direction of the r vector compared to the direction of the dipole axes, all over r squared. So let's solve this. So 1 over 4 pi epsilon naught is 8.988 times 10 to the 9. Dipole moment is 4.8 times 10 to the negative 30. In this case, our theta is 0, so cosine of theta is 1. And r was 4.1 nanometers. Square that. And out of our calculator comes 2.6 times 10 to the negative 3 volts. Cool. Let's go to part B. Part B says 45 degrees above the axis, but nearer the positive charge. So in this case, we have positive charge, negative charge. And 45 degrees nearer the regular charge gives us this of 45 degrees. So now we can use our equation. 4 pi epsilon naught Rp is here, and times the cosine of 45 degrees all over r squared. So let's plug this in. Here's 1 over 4 pi epsilon naught dipole moment times cosine of 45 degrees all over 4.1 nanometers squared. And out of your calculator should come 1.8 times 10 to the negative 3 volts. Cool. Lastly, for part C, similar to part B here, we're going to have our positive charge and our negative charge. And now we're 45 degrees above the axis nearer the negative charge, like this. Cool. So since we always have to measure from the same point, which means if we measure this one from the left side, we have to measure this one from the left side. So our theta actually is 135 degrees in this case. So if we replace from B at theta equaling 135 degrees, everything comes out the same, except cosine of 135 is actually the same magnitude but opposite in sign from cosine of 45 degrees. So we actually get negative 1.8 times 10 to the negative 3 volts. Awesome.